Air conditioning load calculation is going to be discussed. In air conditioning load calculation, uh, the general example will be considered where a household or office building is going to be discussed. Although the air conditioning is aircraft is a little bit different, although the few of the feature of general air conditioning may be used. So in that air conditioning load calculation, these are the basic criteria. First is outside inside design condition, we have already discussed in the previous slides. Then source of heating load and source of cooling load, what are the different sources, that will be discussed. Then heat transfer through structure, it means walls, roof, etc. Then solar radiation, electrical appliances, and infiltration and ventilation. This is the additional load on the cooling or heating system. Then heat generation inside the conditioned space, that is maybe due to the presence of human being or maybe due to some appliances. In this basic of cooling load calculation, basically this is the first calculation which is completed by the heating, ventilation and air conditioning and refrigeration engineer. So when you go to the market and you project yourself as a HVAC and refrigeration engineer, then the user may ask you what calculation that you are going to do. So you need to answer that I am going to do two type of calculation. First is external load and second is internal load. So whenever we want to determine the mechanical equipment size, first we need to determine that what are the sources of heat, from where the heat is going to transfer from the building and from where the heat is going to transfer out of the building. So heat transfer from outside to inside and inside to outside. Then what we need to do, we need to summarize all the heat gain and lost by the building and determine the size of air conditioning equipment. Therefore in this section we need to characterize the internal and external load. So the external load basically, which is the conduction and radiation of heat loss through roofs and wall, windows, skylights as well. In addition, outdoor air can also be brought into the building through ventilation requirement or infiltration. Infiltration means the leakage of the air through porous walls or some other source like gate and air, which will cause the load upon the system. So external heat load, conduction radiation through roof, wall and ventilation infiltration loss. This is the external load. Similarly, the internal load basically due to the latent and sensible heat load from lighting, other equipments, computer, television, etc. and people. Now this is the pictorial representation of various heat gains inside a building. So this is general arrangement of a room. So on the top side it is roof, on the left side one window is showing apart from the wall. So solar radiation is incidenting over this particular room, and so this is the heat gained by the building by external solar radiation through windows, through roof as well as and through wall. Apart from that, internally there are some lighting which is provided, so these lighting may also cause the heat gains, although because heat is lighter due to natural convection, it is going towards the upside direction. Then in the presence of some human being, it may also cause the heat gain in the internally in the building, and some equipment is present, it also plays a role, while ventilation infiltration also is the additional one. If it is there, then it may be considered. So simple factors contributing inside design conditions are: number one, indoor air temperature, then mean radiant temperature, these are the two temperatures basically. Then relative humidity, due to the presence of human being, it also increases the internal heat load in the inside design condition. If more occupants will be there, the load will be higher. Then outdoor ventilation rate provided, so ventilation rate means the total air changes per hour from internally and externally to the room. Then air cleanliness, air path environment, in fact the sound label, apart from air cleanliness and air path environment, if there is some continuous generation of sound, it also plays the determining the inside design condition. Next is the pressure difference between space and the surrounding. So space means the condition in space which is required to be air conditioned, and the surrounding means the outside surrounding. It may be if a single room is there, then the outside the air will be considered surrounding, and apart from the wall, the internal space will be considered as the space. So the pressure difference may also cause some inside design conditions. So pressure difference, sound level, air cleanliness, path and air environment, ventilation and temperature and humidity, these are the inside design conditions. So basically these are the parameters which is required to be evaluated while discussing the inside design conditions. And outside design condition dependent on the following factors. Like first of all, the type of structure. Structure means the structure of construction of walls, whether it's a thick wall, thin wall. So it depends on the type of structure, which is defined by heavy, medium or light. Then insulation characteristic of the building, whether the single stage insulation means only internally or externally insulation is provided, or some insulation is also provided between the two consecutive walls. Then area of the glass and other transparent surface, whether the glass is tinted, painted, opaque or transparent glass, then it may also part of the outside design condition. Then type of user of the space, conditioned space. Then the nature of occupancy, whether it is used for the space preservation of some items, some manufacturing units, or some occupancy level of human being. So if larger gathering will be there, then the outside design condition can be considered. Then daily range, it means the specific range of the temperature which is required to be maintained on daily basis throughout a year. Now this is the summary of picture which I have taken from some of the internet resources. So it is, this particular building consists of a centrally located room where a sensible latent heat gain from the light, equipment and people are considered. This is the main central room. On the left side of the room, this is the part where solar heat gain is considered directly from the glass. So conduction through the door and windows is considered apart from the gain through the exposed wall, because this side wall is exposed to the solar radiation directly. Other walls of this particular house has not been considered by the direct solar radiation. So this wall is directly considered towards the solar radiation. Apart, the other part of the house, which is roof, is considered by the direct solar radiation. So the temperature range is given and the surface temperature is also provided. So roof, ceiling or ceiling gain by solar radiation, this is the wall gain. So obviously this hot area is supported throughout the building, and therefore this particular part is separated by the internal room. So if this heat is being confined in a space, then the heat transfer will be better. This is the past side of the solar radiation, so which is roof and wall are not exposed to the sun, which is close to the outer temperature. So external shade is same as the on the left side and right side, but it is not exposed to the direct sun. Now, apart from these rooms, one basement is provided where some external appliances are there which may generate heat. So cooling may be the required for ventilation. Apart from this basement area is there where no gain for slab floor, below grade wall and basement floor. Similarly, gain through wall and floor from unconditioned space. So one duct is maintained so that the proper air is circulated and ventilated in the basement. So in this type of typical room, all part of inside and outside design condition may be monitored. This is the simple example of heat transfer through a structure. In this structure, one figure is shown where three different type of concrete wall, insulation and gypsum. So gypsum, all these three are being considered where heat is flowing from outside to inside condition. So outside condition, T out is 87 degree Fahrenheit, T in is 75 degree Fahrenheit. So based on that, we can calculate the overall heat transfer coefficient by considering the concrete wall, insulation and gypsum. So we'll calculate the total overall heat transfer coefficient, then it can be used to calculate the load. The load from the roof and walls are conductive loads. The heat from the outdoor is conducted through the roofing or wall material as enter the space. So if the problem assumes no radiation load or does not take into account the time, the only load is conductive load from the temperature difference between the outdoor and indoor has been considered. So in that particular case, we are considering only the conductive load between the outdoor and indoor. So it can be calculated based on Q is equal to UA delta T. So delta T is T outdoor condition, T indoor condition, which is given 87 and 75. Area of this all considered, then overall heat transfer coefficient from the skylight and windows can be broken into the two type of load. One is previous load, conductive load, and now the radiation load. This conductive load, skylight and windows are using the same formula, while this is the for radiative load. So Q is equal to A, SC and SCL, where SC is the shading coefficient, or we can directly consider as a coefficient, and SCL is the solar cooling load factor. Now this solar radiation also contributing the generation of heat externally. Now internally, electrical appliances may generate some heating load. So the heat load from the lighting in a building is found by summing up the number of lights with their wattage and converting these wattage into the British thermal unit per hour, multiplying this number by the usage factor, and if required then special allowances factor. So all the lighting will be considered in this manner. The wattage of the light is based on the manufacturer reported value for the lamp in the lighting fixture. So only main lighting instrument is considered. Then the lighting use factor ratio of time the light is in use, like if we are switching on the lights for 6 to 8 hours, then only that time will be considered. Then typically the factor is 1.0 for most of the applications, office, classroom, stores and hospitals. The user factor may vary for large areas, and the special allowances factor takes like heat from the ballast, then it may the factor typically 1.2 for fluorescent light and 1.2 in incandescent light. This is a typical example of how does it looks like. So the generally lights are considered at the about ceiling height. So this is the spatial factor will be considered. Now apart from this solar radiation electrical appliances, some infiltration and ventilation loads are also considered. So infiltration is nothing but the filtered air. So it means the outside air which may leak into the building structure. It may be due to the defect in the construction, or through porous wall, or maybe through the entry door and windows. So it may be considered by the infiltration equation. The volumetric flow rate of the infiltration or ventilation must be known in order to calculate the total heat gain using the simple enthalpy expression. This value is converted and multiplied by the differential enthalpy, and it is based on the indoor and outdoor air conditions. This is the typical example of infiltration. So the at the topmost side, the outside condition is provided where Q air is there. From ceiling side, the infiltration may occur. So this is the air handling unit, AHU. So it means some duct is connected with that. So it is going to supply some cold air inside the space. And infiltration also some occur from the walls. So due to the relative humidity, it is mentioned here, and the circulation rate is little bit lower. So we can calculate the ventilation and infiltration load based on this equation, which is 4.5 into CFM for ventilation, enthalpy of outside air, and enthalpy of surrounding air, inside air. Similarly, infiltration load, the same expression, 4.5 into infiltration CFM and enthalpy of outside air and enthalpy of space. So what is this CFM is cubic feet per meter. It means the type of amount of air which is required to be used as conditioned space. In the heat generation inside condition, which is heat load from a person, which is depending on the activity level of a person. So for that we need to go through the ASHRAE guidelines, which is American Society of Heating, Refrigeration and Air Conditioning. In the previous lecture it was discussed for different activities what would be the total heat load or total heat gain for a person into different level of activities. Now this load from the people can be calculated using heat gain values, where number of people and cooling load factor can be used. The cooling load factor is the time lag factor if it is given, alright, otherwise it will be considered as 1. So Q is equal to N SHG to CLF, where N is the number of people, SHG is the sensible heat gain, and CLF is the cooling load factor. Generally it is considered by 1, so you need to multiply by number of person and sensible heat gain. In this typical example of cooling load calculation, one example is going to be discussed, which consider almost all type of heating and cooling load calculations. In that example, a cold store of 6 meter length, 5 meter width and 4 meter height have been considered. The ambient air condition is 30 degrees centigrade and 50 degree relative humidity, and internal air is at 1 degree centigrade and 95% relative humidity. Similarly, the wall, roof and floor all are insulated with the insulated material, and overall heat transfer coefficient is given. Ground temperature is also given. So what we need to do, we need to calculate the total cooling load using the data in the different sections. So in first of all we need to calculate the transmission load, then product load. Basically it's a cold storage where different food and vegetable items are going to be stored. So we need to exchange these items continuously. Old item will be replaced by the new items. So the product load due to exchange and the respiration will also be considered. So what we need to do, we need to calculate the cooling load, calculate the value of Q. Similarly, internal heat load due to the people and lighting, then equipment load of fan motors, etc., and infiltration load. So these are the 5 basic load which required for judgment of total cooling capacity for this particular cold storage. So the solution, the detailed solution, is uploaded in a PDF file over the Google Classroom files. So student may consult this file in order to understand the complete problem and the solution. So with this basic idea of air conditioning load calculation, this class ends, and next we will discuss the last part of this subject.